Hello students, I am really super excited to be here just for you. This is Gopal from Department of Chemistry, Bharathidhasanar Matric High Secondary School, Arakkonam. Today we will discuss about 11th standard first unit. The topic is ion electron method. Students, you already know that the redox reactions contains both reduction and oxidation process in a single process reaction. So, in the redox reaction, we can balance by some methods. When we balancing the equations, we use two methods. One is oxidation method and the second one is the ion electron method, in which we will see the ion electron method, how this method will help us to balance the chemical equation. We will see that. Let us see. In this ion electron method, the word ion represent the ions present in the reactants, and you know the ions may be in positive or in negative, and the word electron represent the number of transfer electrons in which the transfer electrons are represented as the word electron. So, this method only includes how many ions involving in this reaction and how many electrons are transferred in this reaction. So, let us go to the reaction. Let us see students, generally the redox reactions contains both oxidation and reduction, in which one reactant can get oxidation by losing its electrons and one reactant can gain electrons and get into the reduction. For example, in these equations, the A loses one electrons to get oxidation and the option B, second reactant, gains one electron to produce the reduction. So, after losing electrons, A attains the positive charge and B, after gaining, it attains the negative charge. So, see that in a single reaction, both oxidation and reduction take place simultaneously. So, this is a redox reaction. In this type of redox reaction, how can we balance this equation? For balancing this, we can use the ion electron method. So, we will discuss about ion electron method and how can we balance this equation. Let us see. For example, for the ion electron method, we will take the same reaction. We already know that about the reaction. It contains K mono4, FeSO4 ferrous sulfate and sulfuric acid H2SO4. Three reactants combined together to form the products. So, same reaction we will take in this reaction. For example, now I have the K mono4 molecule. These molecules contain a K plus and MnO4 minus ions. We can correctly write it as MnO4 minus and K plus. So, students, in which the manganese only changes its oxidation state. So, it is the reactive metal, so it can change its oxidation state, but the potassium and oxygen atoms will not change its oxidation state. So, will be remain the same. So, we only represent about the manganese atom in this method, because the ion changes its electron is manganese. So, ion electron method only concludes the manganese atom, not a potassium atom. So, when we writing this equation, you need not to write the other atoms, only you want to write the atoms who all are changing its oxidation state. So, first we go to the reaction now. Now, I write one example reaction. For example, I take the same reaction already we done with K mono4, it reacts with FeSO4 and with sulfuric acid to form, in which the products are formed by the sulfuric acid, because the sulfuric acid donates the sulfate ions to the manganese atom and the ferrous atom. When manganese accepts the sulfate ions, it can form manganese sulfate. and when the sulfate ions are accepted by ferrous, it is already present as a ferrous sulfate. So, ferrous sulfate is reduced into ferric sulfate Fe2SO4 thrice. So, see students, the sulfate ion is also donated to the potassium ion. So, potassium ion when accepting sulfate ions, it forms potassium sulfate K2SO4. The remaining hydrogen and oxygen atoms are eliminated as its water molecule. So, this is the equation. This equation contains a number of reactants and products. How can we find the number of reactants and products? To find that, the first step is to see the oxidation state of each atoms present in the molecule. Let us see the oxidation state. For example, now I write the oxidation state for potassium, it is always +1. We know the potassium oxidation state is +1. For example, let us consider the potassium chloride molecule KCl, in which Cl contains -1 oxidation state. So, the potassium contains opposite sign but same number +1 oxidation state. And what about the oxygen? It contains -2 oxidation state. We have 4 numbers of oxygen. So, -8 is the total oxidation state of oxygen atoms. For manganese, we can find plus ion potassium, plus ion manganese and minus ion O. Equal number of plus ions and equal number of minus ions only can combine together to form a neutral molecule. So, let us see in which the minus ions are -8, plus ions are want to be as +8. 1 plus is present here, remaining 7 plus is for one manganese atom. So, manganese oxidation state is +7. See students, likewise we can find the oxidation state for FeSO4. For FeSO4, it contains -2 oxidation state. How can we write SO4 as -2? Let us consider about sulfuric acid. Sulfuric acid contains H2SO4. Each hydrogen contains +1 oxidation state. So, 2 hydrogen contains +2 and SO4 contains the opposite sign -2. So, SO4 generally contains -2 oxidation state. So, Fe contains the same number as a opposite sign as +2 and same for the H2SO4 +2 and -2. Same for manganese sulfate +2 and -2. Same for the potassium sulfate, it can have +2 and -2. In ferric sulfate, you can see SO4 contains -2 state. We have 3 numbers of SO4. So, -2 into 3 totally -6 is the oxidation state. For Fe we have +6. Let us see students, you want to note 2 Fe ions contains +6 oxidation state. So, for one Fe ion, its oxidation state is +3. Let note one point. Now, I found oxidation state for all the atoms in the molecules, in which only 2 atoms only have different oxidation states. So, in which the manganese and ferric ion both only contains the different oxidation states in this reaction. How manganese is changed from +7 to +2, 5 electrons are accepted. And what about the ferric ion? +2 to +3, 1 electron is removed. So, 1 electron is donated by the Fe2 plus ion. So, it is converted into Fe3 plus. So, after we concluding the oxidation state, we can get an answer as how many electrons are transferred and how it is changed in its oxidation state. Let us see the next step. What happened for MnO4? MnO4 is present in KMnO4. So, K plus when removed, it get a minus charge. When MnO4 accepting electron, when it forms Mn2 plus. So, MnO4 minus when accepting the electrons, it can form Mn2 plus, in which Mn contains 7 plus charge. Let us see students, and the next conversion is Fe. Fe2 plus it changes into Fe3 plus. When we adding these molecules, let us you consider one matter. Before adding this, let us see Mn accepts 5 electrons, you know. So, Mn accepts 5 electrons. How the 5 electrons comes here? When Fe2 plus loses 1 electron, the 1 electron is donated to Mn. So, Fe2 plus if loses 5 electrons, the 5 electrons all are donated to Mn. So, Fe2 plus want to lose 5 electron means we want to take 5 Fe2 plus. 5 Fe2 plus can form 5 electrons as a donated electrons, and number of Fe3 plus also will be 5 Fe3 plus. So, this is the correct balanced equation for Fe, and you can see 5 electrons when we accepting this, the number of oxygen in the right side you can see 4 oxygens. The 4 oxygens will be removed as H2O. You know well, the H2O is a neutral molecule, and how many plus and minus are present here? When you calculating this, let us see 5 minus ions present here, so minus 5, and 1 minus present here, minus 1, and 5 into 2, 10 plus present here, so plus 10 equal to 10 minus 6 plus 4. So, when we are adding plus and minus ions in the left side, we get plus 4 as the answer. And what about the right side? Right side we have 2 plus, so 2 plus, and H2O is a neutral molecule, so it contains neutral charge. So, the ion contains 0 oxidation state, write 0, and Fe contains 3 plus, 5 into 3 plus we have 15, 5 into 3 plus means 15 plus, and 5 electrons can be written as minus 5. So, what is the final total? 15 plus 2 17, 17 minus 5 12 plus 12. Let us see the difference, students. When I balancing in the left side, we get plus 4. When we balancing the right side, we get plus 12. So, plus 12 is a greater number than plus 4. So, plus 4 needs additionally plus 8 charge in it. How can we get plus 8 charge? When we adding 1 hydrogen in this side, we can give 1 plus charge. When we adding 8 hydrogens in the left side, we can give 8 plus charge. See here, right side the product also contains hydrogen atoms. So, we want to add hydrogen ions. So, I add now 8 H plus, then only we can get plus 8, and the total charges are plus 12. So, I add plus 8 hydrogen H plus ions. So, the number of hydrogens also balanced. 8 H plus ions can form 4 H2O. 4 H2, it means 8 H plus. 4 H2O contains 4 oxygen. The 4 oxygen present in the MnO4 minus. So, the number of oxygens, number of hydrogens all are balanced in this equation. So, now you can get a total for this equation. When we get total, 5 electrons are eliminated, the donated and accepted electrons are eliminated, and you can write MnO4 minus plus 5Fe2 plus 8H plus gives Mn2 plus 5Fe3 plus plus 4H2O. So, after we adding all the molecules, we can get a final equation like this. So, this is a final form of this ionic equation, in which we counted the ions. So, it is the ion method, we counted the electrons also, this is the electron method. So, this method is called as ion electron method, in which we write the half reaction and another half reaction after we find the total for the full reaction. So, half of reactions we written here. So, this reaction method is also called as half reaction method. So, ion electron method's another name is half reaction method. Let us see students, you do the same like problems in book back questions, you do yourself and find the answer for ion electron method questions. Let us see, in the given below description you have the study material. The study material contains the book back and additional questions, and the derivational answers also given in stepwise. The formulas and definitions also given in the study materials. You need to study each of the chapters in the study materials. After studying this, you can write the subject note and write the self assessment. Self assessment photocopy can be sent to us, we can correct it. Thanks for making time to watching this video. Thank you.